Hi, it's GTA Courses, and welcome to the fifth lesson of the .NET Developer series, in which we will cover the most relevant topics to become a .NET developer. So hit subscribe button and bell to see new videos on our channel. Okay, let's go. In this lesson, we will continue learning about the internal elements of the C# class, and now it's time for variables, fields, and properties that the class can have. Fields. A class can store some data. Fields are used to store data in the class. In fact, class fields are variables, just defined at the class level. Let's go back to our modeling concept. No matter what phenomenon we model, usually it has data that would characterize it. The car has the name of the manufacturer, model, registration number, owner, and so on. A bank card has a number, an expiration date, a CVV code, and an operator like Visa or MasterCard. The product in the store has a price, a name, and an article number. All this data can characterize the object that we model in our program. So, it's good when we can store them together within an instance so they are the whole. And class fields do exactly that. They store information and characteristics of the object along with the object itself. The card class from our example has three fields. The number field has an int type. Int is an integer, like 1, 2, 3, 4, and so on. That's it. We can store only such data in it. And if we try to store other data there, for example, like a date or a number with a comma, then the compiler will throw an error and ask us not to do this. It's also important to note that we name fields with a lowercase letter, and when a field name must have two or more words, we use so-called camel case. That is, the first word begins with a small letter, and the second word is written close to the first but with a capital letter. For example, as in the cardholder field. To write the value in the field, we put an equals sign after it, and then write the value we want to store. To use the value that the field stores, we refer to it through a dot and transfer it to where we need it. Properties. C Sharp also has custom fields called properties. The standard property description has the following syntax. In the get block, the actions of updating a value of the property are performed. In this block, we return a certain value using the return statement. The set block sets the value of the property. In this block, using the value parameter, we can retrieve the value passed to the property. For better understanding, value is a keyword, and it's always called value. We don't need to declare it somewhere beforehand. Get and set blocks are called accessors or access methods, and even getter and setter. That is, in fact, the property does not store anything. It acts as an intermediary between the external code and the class field. Through this property, we can control access to the number field, for example. In the property in the get block, we return the value of the field. In the set block, we set the value of the number field. The value parameter represents the value passed to the number field. In the program, we can refer to the property as a normal field. If we assign a value to it, then the set block is triggered, and the value is passed to the value parameter. If we get a property value, then the get block is triggered, which actually returns the value of the variable underneath. It's important to emphasize that properties in C# are named with a capital letter, and if they consist of the two words, then upper camel case is used, for example, like cardholder name. Perhaps the question may arise, why do we need properties when we can get value with regular class fields in this situation? But properties allow you to embed additional logic that may be needed when setting or getting a value. For example, we need to add some card number field verification before setting it. Don't be confused about that if block. It's created when we want a particular block of code to be executed only when a particular condition is met. In our case, the value in the number field will be only written when the value is greater than 0. More about if blocks will be in the next lessons. Automatic properties. Properties control access to class fields. However, if we need a dozen or more fields, then defining each field and writing a property to the same type of it would be tedious. Therefore, automatic properties were added to .NET. They have a following syntax. In fact, fields for properties are created here, only they are not created by programmer in the code, but are automatically generated by compiler during compilation. What's the advantage of auto properties? If they just refer to the auto-created variable, why not directly refer to the variable without auto properties? The fact is that at any moment in time, if necessary, we can expand the auto property into a regular property and add some logic to it. Auto properties can be assigned default values like initialization of auto properties. Read-only and write-only properties. The set and get blocks do not necessarily have to be present in the property at the same time. If a property only defines a get block, then the property is read-only. We can get its value, but not set it. And conversely, if a property has only a set block, then this property is only available for writing. You can set the value, but you cannot get it. Variables. In the previous lessons, and in this one as well, we have already met with variables in which we wrote the class object we created. You may be wondering, what is the difference between a field and a variable when the way we treat them is so similar? So technically, a variable and the class field are the same. It's just a place in memory where a certain type will be written. Before that, we mark variables with the var keyword, which means that any type of data can be written to the variable. It's kind of like a universal toolbox. There are simply rectangular storages, and you can put a hammer and pliers or a screwdriver there. The main thing is that the size is suitable. But the variable can also have a certain type, and then we can only write there only a type we expect. For example, when we buy a set of tools, everything is in a suitcase. Each tool will already have its own place. You will not be able to put a screwdriver instead of pliers because it simply will not hold there or will not fit into special fasteners. To distinguish between fields and variables, we can be guided by the rule that fields are declared only directly in the context of the class without nesting. The context of the class is a curly braces that limits it. Variables, on the other hand, can only be declared in the context of one of the members of the class, like constructors, methods, or properties. We can refer to the field from the outside of the class, but you cannot do this with variable because it's only visible in the context where it's declared. In our case, in the middle of the constructor. Constants. A great feature of variables is that we can change their value while the program runs. But besides that, C# has constants. A constant must be initialized upon definition, and once defined, the value of the constant cannot be changed. Constants are intended to describe values that should not change in the program. To define constants, the const keyword is used, which is specified before the constant type. So, in this example, the constant weekdays is defined, which stores the number of days in the week. Often, the name of the constant is uppercase, but this is not more than a convention. When using constants, remember that we can declare them only once and that they must be defined at the time of compilation. Yes, in the example below, we will get an error because the constant is not initialized. And in addition, we will not be able to change it during the operation of the program. Thus, if we need to store some data in the program, but it should not be changed, we define the constant. If it can be changed, then we use variables. Read-only. Read-only fields and the read-only modifier. Read-only fields represent fields of a class or structure whose value cannot be changed. Such field can be assigned values either directly when they are declared or in the constructor. In other places of the program, you cannot assign values to such fields. You can only read their values. Comparison of constants and read-only fields. Constants must be defined at compile time, while read-only fields can be defined at runtime. Accordingly, the value of constant can be set only when it's declared. A read-only field can be initialized either when it's declared or in the class constructor. Constants cannot use the static modifier because they are already implicitly static. Read-only fields can be both static and non-static. This is all for this lesson. Thanks for watching, hope you enjoyed it. Don't forget to subscribe to the channel and hit the bell not to miss the following videos in the series. Feel free to leave a comment and like this video. And also I encourage you to help brave people in Ukraine to defend themselves in this horrible war. Please use the QR code or links in the description to visit charitable foundations that help Ukraine. Thanks. See you in the next videos.